Thanks for joining me. We're about to go through and do some practice problems. Now, you know we've heavily invested in this. In particular, if you look somewhere down here, you'll discover there's a pause button. That's an amazing feature of this video. You see, what you can do is once you see a problem, pause. Think about how to do it. Better yet, do the whole problem. And then, once you're ready, unpause. And even if you can only do part of it, do as much as you can. The more you can do by yourself, the better you'll get. All right, let's begin. Given that the tangent line to the graph of y equals g of x at the point 3, 6 passes through the point 9, 0, find g of 3 and g prime of 3. All right, so we can do a quick sketch here. So we don't know what g of x looks like. We really know hardly anything at all. We more or less have one piece of information, which is if you go to 3, 6, it has to pass through that point. Moreover, you say, well, the tangent line also passes through that point 9, 0. So if you came over here to 9, and here's 9, 0, and you said, okay, well, that says you could connect the 2 points of that tangent line, and you can actually say exactly what the tangent line is. Okay, so here's our tangent line. Now, what's our big aha? Well, our big aha is that we say, you know, suppose I wanted to make a tangent line. What information would I need? A point and a slope. The point comes from the function. The slope comes from the derivative of the function. So in some sense, we really say, look, the tangent line stores 2 pieces of information, and namely the value of the function at your point of tangent C and the value of your derivative at your point of tangent C. If you know these 2 values, you can make your line. If you have your line, you can recover these 2 values. Okay, now in our case, we're not using F, we're using G, but same principles apply. Well, so what do we do? Well, we don't have to think very hard. See, look, the tangent line has to match the function at the point of tangent C. So in other words, if the tangent line at x equals 3 is 0.6, then the function at x equals 3 is 6. So, okay, all right, great. So that tells us that g of 3 equals 6. All right, now what is the tangent line doing at x equals 3? That's the question we ask. Okay, well, that's fine. What about the derivative? Well, for that, we say, what does the derivative tell us? It tells us our rate of change. It tells us our slope of our tangent line. We say, oh, well, hey, we can compute slope pretty quickly because we say, well, what's happening? We go down 6, and then we go over 6, right? So this is subtract 6. This is add 6. So then g prime of 3, well, the slope is our rise over our run. So we would take, so if we go from 3, 6 to 9, 0, our run, 0 subtract 6, divide by 9, subtract 3, and we get -1. So the slope is our derivative. This is the slope of our tangent line. And we can find slope because we have 2 points, and 2 points, we get the slope. Okay, no big surprises. And now what? Well, we're done. All right. Well, let's hope for more of these types of questions. They're wonderful. Let f of x equal 25x squared divided by x plus a. We're asked to find the value, or possibly values, of a, so that when we take the derivative at 2, we get 9. Well, what should we do? Probably we should say, what's the derivative? So if I want the derivative at 2, first find the derivative in general, and then plug in 2. Now you might be wondering, how do I take this derivative? do I have to use the limit definition or can I use the rules? And here's the answer. If it doesn't tell you to use limit definition, don't do it. Be smart. Don't start. If it does say use the limit definition, we're definitely going to do it. And so this is going to be our principle throughout our problems here. We're only going to use the limit definition if it tells us. So we say, okay, good. So we're trying to figure out f prime of x. And we say, well, that's the derivative, because that's what f prime means, right? It says you're taking the derivative of something. The derivative, and we have 25x squared over x plus a. Now we see a fraction, or fancy term, quotient. So, there's a quotient rule. And so it's good to remember. The quotient rule perhaps is one of the trickier rules to remember. It says if you have the derivative of, say, f over g, there's a couple ways to say it. Some people will say something like low d high minus high d low. You don't encounter that over low squared. But however you remember it, that's what you need to do. And I don't know if I have a great way. Just you get used to it, right? That's how a lot of math goes. Okay, so what's the story here? So if we apply the rule, it says take the derivative of the top. Okay, well, the derivative of 25x squared, 50x. Times it by the bottom, x plus a. Subtract the top, 25x squared, times the derivative of the bottom, 1. And divide all of that by the bottom term, that x plus a squared. Okay, there we go. All right, good. Now we can simplify here, or we can plug in. And you may ask, when do you simplify, when do you plug in? And it's not necessarily that simplifying is always the wrong thing to do, but the question is simplifying a useful thing to do versus just plugging in straight away? My sort of philosophy on that, if you'll allow me to philosophize for just a minute, my philosophy is you should simplify if simplifying helps you take the next step. So if there's something you would do following, maybe take, I don't know, another derivative, and then you'd say, oh, let me simplify because that would make life better. But if you're like, I'm really ready to go, you can plug in. So let's suppose we plugged in without simplifying, and we'll see what happens. Again, if you wanted to simplify, you can. So f prime of 2. Well, we know that's 9. But now we can plug that in. So that's 100 times 2 plus a minus 25 times 2 squared. Well, okay, that's 100, right? 25 times 4. So subtract 100. Downstairs, 2 plus a, quantity squared. All right, great. So we now have one single equation and one thing we're trying to solve for. That's actually pretty good for us. We like that situation. All right, well, now what I would do is I would get rid of fractions. Fractions have always challenged me in life, and they've led to many points that have been lost. So when I can, I get rid of fractions as soon as possible. So suppose you multiply through here by that a plus 2 squared. So 9 times a plus 2 quantity squared equals 100 times 2 plus a minus 100. Well, all right, we can expand things out. So we get 9 times a squared plus 4a plus 4 equals, and 100 times 2 plus a, subtract 100. Okay, let's distribute. We have 9a squared plus 36a plus 36 is equal to 200 plus 100a, subtract 100. All right, we're going to move everything across. And so let's see, what do we have? 9a squared, 36a, subtract 100a. 36 subtract 100 would be negative 64. Huh, okay. Oh, sure, why not? And then we'll have 200 minus 100 is 100. And we're going to subtract, and well, again, negative 64. All right, oh, there we go. All right, great, wonderful. And all that is equal to 0. Now, how do we solve? Well, definitely we gave ourselves a bit of a challenge on this one, but that's okay. We can think about this, and we can try to reason, if we will. Now, there's a couple of ways to approach this, and one is we can try to factor. Probably it will factor, but maybe it's not so clear. And let's suppose we weren't able to see how to factor it right away. I don't see it right away. Well, let's try the quadratic formula. Why not? We learned it, might as well use it. So a equals negative, the coefficient in the middle, so positive 64, plus or minus the square root, that coefficient in the middle again, negative 64 squared, minus 4 times 9 times negative 64, all over 2 times 9. Now I know what you're thinking, hopeless, hopeless. Hold on, let's not lose hope yet. So let's be careful. I'm going to look at this term for a second here. We really have 64 times 64. And we say, okay, so we have 64 times 64. That's our square. And then we have minus, and a minus makes a plus. Then we have a 4 times 9 times 64. Well, what can we pull out? We see that they both have 64 in common. Okay, so let's pull that out. We have 64. We have 64 plus 4 times 9. Now, does 64 have anything in common with either 4 or 9? Well, yeah, 64 is divisible by 4. So that's 64. I'll pull out a 4. And, of course, that's easy to do, that part. Well, how about here? 16. 64 divided by 4 is 16. So this is 64 times 4 times 25. And you say, okay, well, all right, that's not so bad. 64 plus or minus square root 64 times 4 times 25. Now, why is that useful? Downstairs, well, this is 18. Well, when you're taking the square root of plus, square root of multiplication, yeah. So, we have 64 plus or minus, and we have square root of 64 is 8, square root of 4 is 2, square root of 25 is 5, all over 18. Well, 8 times 2 times 5, that's 80. So we get 64 plus or minus 80 all over 18. Okay, nice, nice. Well, we're doing pretty well. And we can simplify, although we're running out of space. Okay, so maybe we'll put it up here. Okay, so we have our work to do. So we had 64 plus or minus 80 over 18. Everything had a factor of 2, so we're going to pull out factors of 2 and cancel. So that's the same as 32 plus or minus 40 divided by 9. Okay, well, that leads us to 2 possibilities. Whoops, shh, quiet. 32 plus 40, 72, divided by 9. 32 minus 40 is negative 8, divided by 9. Well, not a lot you can do with negative 8 over 9, but 72 is divisible by 9. 72 divided by 9 is 8. And so we end up with our answers, namely a equals 8 or a equals negative 8 over 9. And there we go. All right, good. So the process, there's a little bit of work here, but the process is not so bad. Just remember, we're asking for the derivative. Use your rules. Don't use the limit definition. Use your rules. And then that leads us to a formula for a, and then carry out the formula. Life is good. Life is wonderful. Given that y equals 4x minus 5 is tangent to y equals f of x at x equals 2, find the tangent line to y equals x squared f of x at x equals 2. All right, so let's take our first sentence here and let's break it down. So our first sentence, or really our first half of a sentence, I guess, since it's all one sentence, this part right here. We're given that y equals 4x minus 5 is tangent at x equals 2. That's really telling us something about the function at 2. So in particular, the tangent line is mimicking the function. And you say, okay, so what does that mean? Well, it says if I want f of 2, it's the same as if you plug 2 into this expression. 4 times 2 is 8. 8 minus 5 is 3. Okay, what if I want the derivative at 2? Well, to find the derivative at 2, you say, okay, this is storing the derivative in the slope. And so what's the slope? Well, the slope is 4. Say, oh, okay, so f prime of 2, that's our slope. So this is, you plug here, plug in x equals 2 to line, and the 4 comes from the slope. Now, on a side note, it's also true that if you took the derivative of the line, you would get 4, which is the slope. And so that's kind of an idea that will come back to play, especially as we get into next semester. But for now, we should get through what we can. Okay, so that's that information. So in other words, we're taking the tangent line and saying, what does that tell us about the function? Okay, so we know something about what's happening at 2. Now, we're asked to find a tangent line to something else. So let's suppose for a second we will call this g of x equal x squared f of x. So we're trying to find this tangent line. Now, we can find g of 2 if we know what 2 squared times f of 2 is. Well, f of 2, we know that. It's 3. So this is 2 squared times 3, also known as 12. All right, great. So we're halfway, right? We have half the information that we need. But we don't have everything that we need. We also need to find our slope. So that's our g prime. So we say, okay, we need g prime of 2. And so to get g prime, we're going to start with g prime of 2. We're going to get to g prime of x. So we say, all right, well, what is g prime of x in general? Well, notice a function times a function. Product rule. Use your rules. Product rule, the way I like to remember the product rule, everybody gets a turn. So we have two derivatives, two functions, and we're going to say, look, every one of those functions has a time when they get to shine. So we say, okay, x squared, it's your turn. What's the derivative of x squared? 2x. And then the other function stays as is. Now I say, okay, x squared is not your turn. F of x, now it's your turn. What's your derivative? And we say, it's f prime. Say, okay, fine, great. Plug in 2. G prime of 2, that's 2 times f of 2 plus 2 squared times f prime of 2. So we're plugging in everywhere where we see an x, we're putting in a 2, and we plug in what we know. Well, we know what f of 2 is. It's 3. So we have 2 times 2 times 3. We have 2 squared, and f prime of 2 is 4. So we have 2 times 2 times 3, which is 12. 2 squared times 4, that's 16. 12 plus 16, 28. Big number, but that's okay. It's okay. Sometimes you do get big numbers, but the important thing is now we're ready, because what do we have? Well, we have our point, and when we talk about our point is our x value, 2, y value is 12. And we have our slope, it's 28. So if you have a slope and a point, you say, all right, y minus the y value is equal to your m, slope, times x minus your x value, so x minus 2. And now what do? We're done. We can leave it like that. We can, of course, keep going, should we want to. And we could, for example, write this as y equals, well, 28x, and then 28 times negative 2, negative 56, but then that negative 12 comes across as a plus 12, or y equals 28x, and negative 56 plus 12 would be minus 44. All right, and so that's another perfectly fine way to write your answer. They're both fine. They're both the line. So unless they're telling you very explicitly, you must write your line in this form, then write it in a form that you're comfortable with and that you're confident that, yes, I can write it down. No worries. Life is good. I'm going to make it wonderful. And because you are. You're wonderful. Determine the value x for which the function f of x, x cubed minus 12x squared plus 11x plus pi cubed, has the lowest instantaneous rate of change. Also, give the instantaneous rate of change at that point. All right, so instantaneous rate of change, what does that mean? When we see that expression, we say, oh, this is asking about the derivative. So we want to say something about the derivative of the function. So probably we should start by finding the derivative if we can. And yes, we can. So given our function, we can say that f prime of x is 3x squared minus 24x plus 11 plus derivative of pi cubed. Now, you might say, oh, I know that rule. The 3 comes down, right? So it becomes 3 pi squared, right? Right? Why are you looking at me? What? What? It's not? No. Pi cubed is what? A constant. So what's the derivative of a constant? 0. So be careful. They can make constants look suspiciously non-constant-like. And so you want to make sure you're applying the rules correctly. So that pi cubed was sort of a distractor. But we won't be distracted. We know it's a constant. And at the end of the day, constants are pretty easy to deal with, especially when we take derivatives of constants. Now, what are we after? The lowest instantaneous rate of change. And we say to ourselves, hey, you know, this is a quadratic. It means it's a parabola. So I don't know exactly which parabola it is, but I can tell it's an upward facing parabola, right? So it's doing something like that. So if I'm after the lowest instantaneous rate of change, I'm basically trying to find this point, which is the bottom of the parabola. Okay, so that's not so bad. How does one find that? Well, there's a couple of ways to do it, and this is foreshadowing things to come. We're going to have better tools in the future, but for now, we can just say, you know, we know parabolas. We've been hanging out with them for years. We're almost like on a first-name basis. Hey, Pierre, what's up? Not much, Steve. What's up with you? Hey, I'm doing great. So, what's the punchline here? Other than I can't tell good jokes. The punchline is, let's think about another way to write this parabola. And in particular, we're going to do something called completing the square. So this will help us figure out what's going on with this function. Now, as a quick refresher, if I have something of the form I'll say x plus a quantity squared. Well, that becomes x squared plus 2ax plus a squared. So I say, oh, if I have x squared plus something x, how do I figure out what to add to get a square? Well, I take that coefficient of the middle term, divide by 2, that's your a, you square it, that's what you should add. Now, notice they did something to us here. They put a 3. Oh, they did that, didn't they? Yeah, they did, but that's okay. We saw it. And because we saw it, we can adapt. Say, all right, so we're going to write f prime of x as 3, and we're going to factor out that 3. X squared minus 8x, suspiciously long gap, plus 11. Okay, so ignoring the 3 and the 11, focus on this part. What should we add right here if we wanted to complete the square? So you see the x squared minus 8x, that's like your x squared plus 2ax. So minus 8 is your 2a, so a is negative 4. So I should add a squared. So I should add 16. Oh, wait, if you add 16, what should you also do? You should subtract 16, right? See how add 16, subtract 16, boom, that's adding 0. Yeah. And we did it inside the parentheses, so that way we would make sure we didn't do anything that would mislead us. Okay, so the first part becomes x minus 4 squared minus 16 plus 11, keeping our parentheses in the right place. Or we could say, hey, this is really 3 times x minus 4 squared minus 48 plus 11. Or this is 3 times x minus 4 squared minus 48 plus 11 is negative 37. Okay, good. Now what? Well, believe it or not, we're ready to write our answer. Because we said, well, where's the bottom of the parabola? If you think about this expression here, notice that the key thing to observe, this x minus 4 squared, is it's always greater than or equal to 0. So this part right here, it's always adding things. It never subtracts. That's the power of squaring. So you say, if I want this to be as small as possible, which is at the bottom, this part should be 0. So I say, oh, okay, so to minimize your derivative, because this is the derivative, so we were looking for x equals 4, because that's what makes the inside 0. And then if x equals 4, this part goes away, and so we should say absolute min occurs at x equals 4. The absolute min value, absolute min of instantaneous rate, absolute min value of the instantaneous rate, I should have written that, but that's okay, is negative 37. So we had to have both pieces of information. Where did it occur, and what's the minimum instantaneous rate of change at that point? So that we could even say, just to be clear, this is f prime of 4. And that's it. There you go. Wow, great. Actually, as long as you understand you're dealing with a parabola, you can make this work. It's not too bad. Now you might say, but wait, what if we're not dealing with a parabola? Well, then you have to do other things. But we will teach you other things. Stay tuned. Great stuff is coming. Suppose that h of x is f of x over x, and g of x is f of x over x squared. And we're also given that h prime of negative 1 is positive 3, g prime of negative 1, negative 11. And then we need to find f of negative 1, f prime of negative 1. All right, good. Well, let's take this and let's figure out what h prime of negative 1 is. And I suspect it'll have something to do with f, right, because there's an f involved. And looking at this, we say, okay, let's first figure out what's the derivative of h, and we'll start there. So we have h prime of x. That's the derivative of f of x over x. Ah, quotient. Be careful, right? So we're going to start taking the dirt of the top times the bottom minus the top times the dirt of the bottom, and all of that's going to be divided by the bottom term squared. Okay, and while we're at it, let's do g prime of x. G prime of x is what? That's the derivative of f of x over x squared. So again, dirt of the top times the bottom minus the top times the dirt of the bottom. All of that over the bottom squared, x squared squared. So that would be x to the fourth. Okay, so we now have our h prime and our g prime. So the next thing is we're going to plug in. So we say, okay, well, we're going to evaluate at minus 1. So we get the following. 3, that's equal to h prime of negative 1, which is, plugging in here, f prime of negative 1 times negative 1 minus f of negative 1 times 1, all over negative 1 squared, which is 1. Okay, all right, that's great. And similar, what do we have? Well, we have negative 11, which is g prime of negative 1. Well, plug it in. That's f prime of negative 1 times negative 1 squared, which is times 1. Then we subtract f of negative 1 times negative 2. And all of that, negative 1 to the fourth, which is 1. Okay, so let's rewrite what we have now. So this first equation, well, that says minus f prime of negative 1 minus f of negative 1 is equal to 3. Okay? And the second equation, well, that's f prime of negative 1, and minus times minus 2 makes a plus 2. F of negative 1 is equal to minus 11. Ah, good. So we've turned these two pieces of information into two equations. Two equations, two unknowns. And the solution is what we're trying to find. Perfect. Woohoo! Nice. All right, well, we actually still have to solve, right? We still have to figure out what's going on. So I like to eliminate in this scenario, and I notice these two look really well set to cancel each other out. So let's add them together. We get cancellation. Here, minus f of minus 1 to f of minus 1. That's f of minus 1. 3 minus 11 is negative 8. All right, we're halfway done. Well, okay, but let's now plug in. Where do we plug in? Doesn't matter. So we could say, for instance, f prime of minus 1 plus 2 times negative 8 is negative 11. Well, that's the same as saying f prime of negative 1 minus 16 is minus 11. You move the 16 across, f prime of negative 1 is negative 11 plus 16, also known as 5. And now we're done. Let's just write our answer, put them together. So our f of negative 1 is negative 8, and our f prime of negative 1, that's equal to 5. And we're good. We're done. We're done. Good. Good. All right. Woohoo! Let y equal f of x be a function that is differentiable at all real numbers. Okay, so everywhere has a derivative. Suppose f has the form x squared plus bx plus c if we're less than or equal to 3, 6 minus c root 3x if x is greater than 3. And we're asked, find the values of b and c. Okay, so, well, what's going on here? Well, we have two pieces, and individually, they're fine. Polynomials, great, beautiful. Now this has a square root, but notice the square root is always going to have positive terms. We're interested in it. So again, beautiful. So individually, life is good. Now the problem is we're trying to hook them up. So we have to do two things. One, we have to make sure they line up. So we don't want this, we want this. So that's step number one. And the second thing is that we have to make sure that when they line up in a nice straight way. So we don't want this, we want that. Okay, so what does that mean? Well, it turns out we can write two conditions. Now that's good, because we have two things to solve for. So first off, to get them to line up, that says we need to have that the limit as x approaches, and our gluing point is 3, so we're talking about our gluing point, 3 from below of f of x. Well, that has to match the limit as x approaches 3 from above of f of x. Okay, so that's condition number one. Let's go ahead and work this out. So when we're approaching from below, what needs to be true? Well, when we're approaching from below or from the left, we look like our polynomial. So that's our x squared plus bx plus c. And for that limit, no issues, right? Plug it in. You should always plug in first and then say, do I have to do more work or not? And unless you have some 0 over 0 or infinity over infinity, something strange, you just plug it in and life is good. Isn't it great? Everything makes sense. It's a good life. Okay, so here we go. 9 plus 3b plus c. Okay, so we just plugged in x equals 3. 9, 3b, and c. All right, on this right-hand side, what is our function behaving like? Well, it's this other part. 6 minus c times root 3 times x. Okay, well, plug in. What happens? You get the 6 minus, now 3 times 3 is 9, square root of 9 is 3, 6 minus 3c. All right, and of course these have to be equal, and so we say, all right, well, let's put them equal, and we can rearrange. So I can move the 3c across, I'll keep the 3b there, so 3b plus 4c, move the 9 across, 6 minus 9 is negative 3. Okay, so here's our first constraint. 3b plus 4c has to equal negative 3. If they don't, it's going to do that. We don't want that. We want them to agree. Okay. Now, that's making sure the pieces are. Now we have to make sure that we don't have a kink going on. So for that, say let's look at the derivative. Now, when you have piecewise function, you have piecewise derivatives. And so you say, okay, well, hey, this tells us something about what f prime of x looks like. It looks like what? Well, 2x plus b, and the derivative of c is 0. All right. Derivative of 6, 0. Then we have minus c. And this, by the way, we can write this as root 3 times root x, which is x to the 1/2. So for a second here, I'll write it as root 3. And then derivative of this will be 1 over 2, x to the minus 1 over 2. All right. Now, this is if we're below 3, and this is if we're above 3. I want to point out one small tiny thing here. You might notice that there's a little thing that I did. Not in terms of the derivatives. I mean, the derivative is perfectly fine. That's not our issue. What is? Notice there you have less than or equal to, and here you do not have less than or equal to, right? It's just a strict less than. That's not a mistake on my part. The problem is you don't know what happens as they come together. So you have to check, right? It's only if everything gets nicely lined up that you would actually have equality there. And that's what we're doing. That's what we're working towards. Okay, so now we say what? Well, we need the limit as x approaches 3 from below of f prime of x. That better equal the limit as x approaches 3 from above of f prime of x. And, okay, well, what does this become? Well, we're going to do the same kind of thing we did here. That's the limit as x approaches 3 from below, and we look like 2x plus b. Okay, well, that's easy to figure out. Plug in x equals 2, and we get 6 plus b. Now, on this side, we say, okay, similar idea. We have the limit, x approaches 3 from above, and, well, okay, we can write this as minus c over 2, our constants. Then we have a root 3 over root x. So the x to the minus 1/2 is like a root x downstairs. Okay, plug in x equals 3. Well, you get root 3 there. And root 3 over 3 is 1. So you get minus c over 2. And again, these need to be equal. Whoops, I can make my 2's look like 2's. Okay, so, well, same thing as we did over here. But first, let me multiply both sides by 2, because fractions always make me nervous. So 12 plus 2b is negative c, or 2b minus c needs to equal, plus c because I moved it over, negative 12. All right, so there's our other constraint. So now what do we have? We have two equations, two unknowns. What are the odds? Well, pretty high actually. We love two equations, two unknowns. They show up frequently. All right, so let's put them one on top of the other. We have our 3b plus 4c equals negative 3, and our 2b plus c equals negative 12. And we have to look for ways to simplify. So I look for ways to cancel. It looks like the c's we could probably cancel pretty quickly if we did the following. Suppose we multiply this part by negative 4. Okay, and add. Why? 4c minus 4c. Oh, yeah, that's pretty convenient. 3b minus 8b. That's minus 5b. Minus 3, and then plus 48. All right, well, 48 minus 3, that's 45. That tells us, b better be negative 9. All right, well, now let's plug it in here. Negative 18 plus c has to be negative 12. We can add 18, and then we get c equals negative 12 plus 18, and that tells us that c better equal 6. All right, good. So our final answer, because we were asked to find the values of b and c, b is negative 9, c is positive 6. And there we go. There we go. So remember, if you have something which is piecewise and you're trying to make it differentiable, you have to have the functions need to line up, the derivatives need to line up. That gives you relationships, and you can solve those for your constants. All right. Wonderful. Nice. Find the point a comma b, so we're looking for coordinates, on the graph of y equals x cubed minus 6x squared plus 20, where the tangent line is perpendicular to the line x minus 12y equals 7. Okay, so what do we have? Well, we have a curve and a line. And let's for a second get a little bit into this line. So this says x minus 12y equals 7. And so we could rewrite this as 12y is equal to x minus 7, or y equals 1/12 x minus 7/12. Okay, so it's a line with a fairly shallow slope. And so we say, okay, so there's this line somewhere out here. Here's our line. And then we have a cubic. And roughly speaking, a cubic will look like some cubics do. And okay, who knows? It's doing something. And what's our goal? Well, our goal is to find a place where the tangent line to that cubic is perpendicular. So it's not parallel. Parallel say same direction. So we're looking for something roughly like this. This is our goal. This kind of line right here. All right. So bad picture, but we can use bad pictures to build up good intuition. So we say, okay, so our goal is we want this kind of a line. So what's the slope, our desired slope? Well, our desired slope for our line, we find it by saying take your current slope, right? This is the slope of their tangent, and you do the negative reciprocal. Change the sign, flip it over. So our desired slope is negative 12. Okay, that's what we want. So here's our idea. We say, okay, if our f of x, this is our x cubed minus 6x squared plus 20, we're looking for where f prime at a, because that's our x coordinate, equals negative 12. All right. Well, let's find out. Now, we'll find out if maybe there's even more than one. It's possible. Sometimes there's multiple ones. Okay, so we kind of have our plan, right? We figured out if we need to be perpendicular to the line, it's all about the slope. We figured out what slope we needed. We said, well, we know how to find slopes of tangents. Slopes of tangents come from derivatives, so we need to set our derivative equal to the right value. And, well, okay, let's start the hard part, where we actually figure out the general derivative. Okay, derivative 3x squared minus 12x, and derivative of 20 is 0. Yeah, don't forget derivative of constants are 0. So we needed f prime of a, that's 3a squared minus 12a, that needs to equal negative 12. Well, okay, that's the same as saying 3a squared minus 12a plus 12 needs to equal 0. Everything has a 3. So let's divide out by 3. If you see common factors, it's nice to get rid of them because it makes it a little bit easier to spot what's going on. And now we say, okay, when does this equal 0? Does it factor? And does it factor nicely? Well, it looks like it does factor, actually. So it looks to me, it looks like a minus 2, right? Because we need two things that multiply to 4, but add to negative 4. We can, of course, check. A squared, good. Minus 2a, minus 4a, great. Plus 4. Nice. And actually, it turns out that it's a double root. So even though we potentially had 2, we could have also had potentially 0. We got 1, the 1 root. So that's good. So now we know, hey, a equals 2. Are we done? No. Remember, we have to answer the question based on how it was asked. Now, it didn't ask for just the x coordinate. What did it ask for? It said, hey, I want the point. Give me the whole point. So we found A. We also need B. So how does one get B? Well, the way we get B is to say, look, the y coordinate is found by plugging in the x coordinate to our function, not the derivative, to our function. And we say, okay, well, what do we get out? So let's figure this out. So in our case, B, that's our f of 2. That's 2 cubed minus 6 times 2 squared plus 20. So 2 cubed is 8. 2 squared is 4. And then we subtract 20. Times it by negative 6. Got ahead of myself. Minus 24. I'm just so excited. Add 20. This is 28 minus 24, and so that gives us b equals 4. So there we go. There's our a and our b. So we'll say our final answer, AB, is the single point 2, comma 4. And we found our point. Woohoo! Nice! Suppose that f of x has the form x cubed plus a over x, where a is a constant. And we're told f double prime equals 2, and we need to find the value of a. Now, a quick notational note. This double prime, we haven't actually said this yet out loud. There's 2, right? What does that mean? Like one little dash, that's 1 prime, 1 derivative, right? So what do you think 2 primes means? 2 derivatives. So the idea is we're going to take 2 derivatives of our function. I mean, the derivatives, the idea is so nice, we'll do it twice, right? So, okay, so our goal here is let's take 2 derivatives of f. And we're going to plug in 2, set it to 4, solve for a. Okay, that doesn't sound so bad. Now, I want to make an observation. And that is, the way this function is currently written, it looks like quotient, right? And like, this could be messy. But remember, there's a strategy. And I'm going to go ahead and write this down because this deserves to be written down. So our strategy is simplify if possible. And another way to say this is, we want to make life easy on ourselves. Why? We love ourselves. Oh, we're the best. You're the best. Okay, so because we love ourselves, we don't want to make life harder. We want to take care of ourselves. So we say, okay, before I get too far down, is there anything to simplify? So we always sort of keep it in the back of our heads. And I can't help but notice this over x seems like it's something that we could rewrite. Because what can we do? Well, this we can split into 2 parts. This x cubed plus a over x, that's the same as x cubed over x plus a over x. And so splitting it makes it look a lot nicer. X cubed over x, that's x squared. A divided by x, well, that's saying you have an x downstairs, that's x to the negative 1 power. And now, no quotient rule. None, right? And like quotient rules are like, oh, but this is like no quotient rule, like, yeah. So we're happy about that. The power of being kind to yourself. It's a wonderful thing. Okay, so let's talk derivatives. So if we're taking a derivative of x squared, 2x, classic. Now, derivative of x to the minus 1. This is one that, it's not too bad once you get the hang of it, but pay attention, right? We're going to take our power, negative 1, and it's going to come down. So that's going to put a minus 1 times a, so that becomes minus a, x to what power? This is where you have to pay attention. You always subtract 1. It's natural to say, oh, well, like x squared became x to the 1, right? So it's like you should get smaller. So negative 1 maybe goes to 0. No, negative 1, subtract 1, and that would give us negative 2. Okay, well, we're not done yet. F double prime. Oh. Okay, derivative of 2x, 2. And again, we have this negative 2 upstairs. It's going to come down. Negative times negative 2 plus 2a. X to what power? Minus 2, subtract 1. Negative 3. Okay, so we've now found the generic form for f double prime. So at this point, we need to plug in our 2. So we know that 4 is equal to f double prime of 2. Well, that's 2 plus 2a times 2 to the negative 3 power. Now, let's just point out what 2 to the negative 3 power means. So that's 2 plus 2a divided by, so negative means you move it downstairs, 2 cubed. Well, there's already a 2 upstairs, so we can simplify it again. Cancel off 1, 2, so that gets us down to 2 squared. So that's a over 4. All right, so 4 equals 2 plus a over 4. Well, we can subtract 2 from both sides. We get that a divided by 4. 4 subtract 2 is 2. Multiply 4 across, and we get that a is 8. And we're done. We found what we needed. When a is 8, then the second derivative at 2 is 4. All right, nice. And it wasn't so bad. And it wasn't bad because we took care of ourselves. So don't forget, you're worth it. You're definitely worth it. Be good to yourself. Lots of words on this problem. Let L1 be the secant line to the graph of 4 plus 6x minus x squared through the 2 points where x equals 2 and x equals a. Let L2 be the line tangent to the graph of y equals 4 plus 6x minus x squared at x equals 2. Find the value of the constant a so the lines L1 and L2 are perpendicular. Whew! Okay, we have lots going on here, but let's see if we can't sort of get some notion of what's going on. We definitely have the following. We have the same curve, so that's good, and it's a downward facing parabola. All right, so it's doing something. And I don't know exactly where 2 is on here, but let's say this is at 2. I don't know. I'm just guessing. But right now, I'm not worried about getting it exactly right. I'm just worried about getting the intuition right. And so what's going on here? Well, the L2 line is the tangent line. So this would be L2. And so the tangent line is very easy to find. And then what's L1? Well, L1 is perpendicular to L2, and it actually has to cross this point. So we say, okay, well, so we come through and we're perpendicular. Okay, I'll be very generous with my drawing here. And what happens? Well, this is the line L1, and it crosses the curve somewhere else at some other point A. And our goal is we have to find this A. So this is the problem. Now, my picture might be wrong. It might be that A is again negative. I just want to make sure I understand what's going on. That's why I draw a picture. You know, even a bad picture can be useful for understanding what's going on. So let's figure out some key things. So for L2, we're interested in a tangent line. So in particular, if we want to find L2, we would do what? We'd look at the slope of it was the instantaneous rate of change. And in fact, this is really the underlying problem here is about average rate of change versus an instantaneous rate of change. So this is an instantaneous rate of change. And, well, okay. And so our slopes, if we let f of x equal 4 plus 6x minus x squared, our f prime of x, well, that's 6 minus 2x, the derivative of 4 is 0. And so f prime of 2, well, that'd be 6 minus 4, which is 2. Okay, so good news, we now know the slope of L2. So, woohoo, nice. Okay, so our slope of L2 is 2. Now, why am I emphasizing slope? I'm emphasizing slope because we are interested in perpendicular, and perpendicular is a slope aspect. Do I need to find the line? No. The question actually doesn't ask me to find the line. And finding the whole line doesn't actually help me at this stage, because the only thing that's important about this line is the slope. So we found the slope, so we can stop with line 2. All right, so instantaneous rate of change. It's actually a little bit easier than average rate of change because you only have to worry about that one point. As long as you know where your point is, and we do. It's at x equals 2, then we're good to go. Now, L1, what is that? Well, it's a secant line. So when we talk about secant lines, we're comparing at two different points. And this is really average rate of change. So we say, oh, okay, so it's an average rate of change. And in this case, we have to know between where? Well, between 2 and A. All right. So we say, okay, good. And what's our goal? Well, to be perpendicular to this slope, well, we'd be the negative reciprocal. So we're going to take 2, flip it over, and multiply by minus. So we say, okay, so our average rate of change would be f of A minus f of 2 divided by A minus 2, and that better be equal to negative 1/2. Okay, good, good. All right, well, right, slope of our secant line, perpendicular to our line 2. Okay, well, now we plug in. So we have 4 plus 6a minus a squared, subtract, well, when you plug in, you get 4 plus 12 minus 4 all over a minus 2 equals minus 1/2. All right, well, the 4's cancel. That's nice. So we have 4 minus 12, that's negative 8, plus 6a minus a squared over a minus 2 equals minus 1/2. Okay, so we have fractions, and when we have fractions, what do? We cross multiply. Okay, great. All right, so let's do that here, and let's see what we get. And all right, we'll get minus 16 plus 12a minus 2a squared, so we're putting the 2, equals here minus a plus 2, all right? So we multiplied by 2, multiplied by a minus 2. All right, well, great. What is that going to give us? Well, let's move everything over to one side. So we get that 0 is equal to 2a squared. And then we have 12a, subtract a, minus 13a. And we have minus 16 comes over as plus 18. All right. Whew. Does it factor? Well, maybe. And, well, actually, more than maybe. There's a kind of a clue that it will factor. I just want to point out, we have one easy root. And you might say, wait, what? We do? Where? Well, suppose we come here, and I'll put this sort of comment over here. Notice we haven't done any cancellation yet, so that's good for us, because this is the same as f of a minus f of 2 is minus 1/2 times a minus 2, right? Because essentially that's what we've done. Look at this equation for a second. Look at it. Look at it. Look again. Okay, what? I claim that there's a value for a that solves this. You see what value for a does it? 2, right? Because you get f of 2 minus f of 2, which is 0, and 2 minus 2, which is 0. So let's actually check. Does 2 work? So 2 times 2 squared is 8. Minus 13 times 2 is minus 26, and then we have 18. 8 plus 18 is 26. Subtract 26 is 0. So that tells us that a minus 2 is a factor. Since a equals 2 is a root, a minus 2 is a factor. And so in general, you should say, hey, I know a factor. So we get a minus 2. And now we say, well, how do we make the rest of it? Well, we need to get that 2a squared. So a times what gives 2a squared? 2a. We need to get plus 18. Okay, minus 2 times what gives us plus 18? Minus 9. And now multiply, right? Check it out. 2a squared minus 9a minus 4a, that's minus 13a plus 18. You can do quadratic formula if you don't like what we just did, but you can say, hey, is there an easy root? And oftentimes you're like, well, let me try this out. And that gives you a nice way to start your factoring. All right, so this leads us, two things multiplying. Together we got 0. And so one of them had to be 0. Well, that says you either have 2 or 2a minus 9 equals 0. That's 2a equals 9. That's a equals 9 halves. Is 2 correct? No, it can't be correct, because you can't do an instantaneous rate of change from 2 to 2. Oh, sorry, not an instantaneous. You can't do an average rate of change from 2 to 2. So can't be 2. Can't be 2. Well, that leaves us with just our one possibility, and that was 9 halves. So, and that's all we were after. We were just saying find the value of a. So our value for a is 9 halves. And there we go. Life is good. We got it. Woohoo! Yay, us! Nice! Let f of x equal x squared over x plus 4. Use the limit definition of the derivative to find f prime of 4. Oh. So we have so far been avoiding using the limit definition, and there's a good reason for that, because that's work. But our time has come. Okay. And it says no credit will be given for methods not using the limit definition of the derivative. Okay, so we definitely better do it because we love credit. We want to get all the credit, right? Okay, so let's figure this out. Okay, so the limit definition. And note that we're finding the derivative at a single point, not the generic derivative function. So that will probably help us a little bit. So what do we have? Well, we have f prime of 4. So the first step will always be the same. And this step, I'm going to put a long equal sign just because I want to write underneath, we're going to write down the definition. Okay, so you always start with the definition. So this has nothing to do with the function. You always do the same thing. You say, okay, limit as h goes to 0, f of, in this case, 4 plus h minus f of 4 all over h. Okay, so that's always the same thing. The next thing is also essentially always the same thing. What's the next thing? We'll replace these f's using the function. And okay, and the part that throws some people off, but not us, because we're ready for it, is when you plug in 4 plus h, what do? That says everywhere where you see an x, you put a 4 plus h. So this is 4 plus h squared, divide by 4 plus h plus 4, subtract, plug in f of 4. Well, that would be 4 squared, and 7 years ago, oh wait, no, that's something else. 4 squared is 16, and 4 plus 4 is, well, it's 8, all over h. Okay, so definition always comes first, plug in always comes second, and now what comes next is algebra. Da, 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 algebra, right? Da, 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 da. Now, why are we doing algebra next? Well, the problem is we're always having a 0 over 0 at the start. So sort of our goal is we say, what do we want? Well, what we want is we want to get an h upstairs, an h downstairs, and so that we can say, oh, those h's, that's what's causing our 0 over 0. So we're trying to get to a stage where we can cancel off h's. That's always our thought process. Got to cancel some h's. Got to do it. So we say, all right. So to get to that, we've got to keep rewriting until we've gotten there. So let's think what we can do here. And so let's start by squaring that. That would be 16, right, 4 squared. And then you have 8h and h squared. Downstairs you have 8 plus h. Subtract 16 divided by 8, well, that's 2. Now, we have an h there, so we have like a fraction inside a bigger fraction. I tend to not like that. So what I'd like to do is I want to take this h, move it up. So how do we take this h and move it up? Well, you flip it over. You can really think of this as like h over 1. So when you move it up, it becomes a 1 over h. All right, so this h over 1 downstairs is the same as 1 over h upstairs. All right, well, good. Now, what do we have? Well, that's next step, right? Let's combine, add. And in this case, we say, oh, well, let's get a common denominator of 8 plus h. So this is 16 plus 8h plus h squared, divided by 8 plus h, subtract 2 times 8 plus h over 8 plus h times 1 over h. Okay, so that's the same as h goes to 0. And now it's just one big 8 plus h downstairs. And this h can also join that 8 plus h downstairs. And then we have what? Well, we have 16 plus 8h plus h squared minus 16, that's 2 times 8, minus 2h. Okay, so that becomes what? Limit as h goes to 0. Oftentimes, I'm taking a few extra steps just to make sure we can follow along. You don't always have to do all of this, but you should do enough to make sure you can follow. 16, subtract 16, that's good. And, well, 8h, subtract 2h is 6h. And then you have plus h squared. Downstairs, you have 8 plus h times h. You say, oh, wait, look, there's an h that we have in common upstairs. So that's the limit as h goes to 0 of, well, I'll factor it out on the end, 6 plus h times h, 8 plus h times h. And remember what our goal was. Our goal was to get to a point where we said, oh, we can cancel h's. 1h upstairs with 1h downstairs. Because this, in essence, is what's causing our 0 over 0. So if we cancel, pew, pew, there's no more 0 over 0. Yes! Yes! Good! Now, I should have pointed out that we should have been really excited here, because everything had an h in it. If something was there which didn't have an h in it, mistakes were made. And okay, well, if mistakes were made, we go back and we catch our mistake. And so it's one of those things where you know you have to get to this point. So if it's not there, then you can say, okay, I missed something. And you look for it. All right, now we're not done yet because we haven't plugged in h goes to 0. I'm going to write it one more time, but usually you just plug in h equals 0 at that stage. 6 plus h over 8 plus h. This becomes 6 over 8, also known as 3 over 4. And we're done. And that's it. That's the whole idea. Now, I will say there is a check. So there's a check that we can do. What does the check look like? Well, it says, we know how to take derivatives by using quotient rule. So let's just do a check. Now, this is not part of the problem, but this is like, I want to make sure I got the right answer. So we say, okay, take the derivative. So f prime of x, quotient rule, we take the derivative of the top. So derivative of the top, 2x times the bottom minus the top, times the derivative of the bottom over the bottom term squared. So let's plug in 4. All right, 2 times 4, 8. 4 plus 4, 8. 4 squared, 16. 4 plus 4 is 8 squared. So that's 64, subtract 16, that's 48. 8 squared is 64. And then you say, oh, well, they all have factors of 16. Divide top and bottom by 16, you get 3/4. And we're like, yes. So taking the derivative using the quotient rule and plugging in is the same thing we got by using the definition of the derivative. And you might say, oh, doesn't this seem simpler? It does, doesn't it? And that's sort of the whole point. We're learning the rules to make things simple. Because after all, remember, we do love ourselves. We want to take care of ourselves. All right, good. Woohoo!